Did I bring the homework due tomorrow?
Huh?
Bring the homework.
I'm not gonna collect the homework. I'm tired of babying you guys already.
I like the test.
No. Yeah, you're just gonna hand it in the day of the test.
Yeah.
If you guys sync tomorrow, that's your own fault. What are you doing? Get over there!
I wanted to see what my overall was. Not bad. Not good, not bad.
Oh, that's real good. Okay, you guys didn't write any numbers up there, so you gotta tell me what numbers they were.
26.
What?
26.
46. We're at 46 already?
26.
26.
No, it's because it's play-based. I know.
Okay, thank you for writing down the assignment. 26. Okay, constructing a cell. Okay, got two problems here. So you have a rectangle like this. This is x and they equal y. Are you guys looking at the diagrams at the website? Or you guys don't even know there's diagrams on the website? Hayakawa.
The diagram from the book.
But not for all the problems.
Okay.
Oh man. Okay, it says you're gonna roll it into a cylinder. What values of x and y give the largest volume? So you're gonna start with a sheet of paper like this and you're gonna roll it into a cylinder like this. So isn't this y right there? Okay, and then so how do you figure out the volume of a cylinder? You need to figure out the radius right there. But how do you do that? Well, isn't the circumference of this circle on the bottom the same thing as that right there? You roll it. So the circumference of the circle, which is 2 pi r, has to equal x, the bottom part of the paper. So therefore, r equals x over 2 pi. So the volume of the cylinder is pi times the radius squared, but here's the radius, times the height. But again, just like all the other problems we've been doing, you got two variables. You have to get rid of one of them by writing another equation. And where does that come from? Well, if you read the problem, it says the perimeter of this sheet is 36 centimeters. So what equation can I write? What's the perimeter of the sheet? 2x plus 2y equal 36, which means x plus y equal 18. And shall we solve for y? Y equal 18 minus x. It really doesn't matter which variable you solve for. Take that and plug it in. Right there. And so you get pi times x over 2 pi squared times 18 minus x. Do I need to finish it? Just finish it. So you can copy it.
Yep.
Who said yes? Okay, now before you start, I would highly suggest you simplify. So this would be, now remember when you square a fraction, you have to square the top and the bottom now. So that's x squared over 4 pi squared times 18 minus x. This pi cancels into one of those pi's. So that's going to be 1 over 4 pi times, I'm going to distribute the x squared in here, 18x squared minus x cubed. I am not going to... See, if you think ahead, you throw the constant. You can throw the constants on the side anyway, right? When you factor the derivative. So you take the derivative. Why is it so warped? Throw the constant on the side like an unwanted path, and then take the derivative of that, which is 36x minus 3x squared. Let's see if I can make less mistakes today. What can I factor out? You can factor out a 3 and an x, and what's left? 12 minus x. And so when you make your number line, and tomorrow, where's Zhang? Tomorrow when you make your number line, I'm checking to see if you label it now. You don't label it as automatic minus 1. Well, you got to label it correctly. You can't just label it anything you want, like happy face or whatever. 0 and 12, so it'll be minus plus, and we really don't care over there because x cannot be negative. And so this means, did you guys figure out the trick yet?
Wait, in this problem the x is the circumference? Because it's
Oh yeah? It is the circumference. But isn't the problem to find the values of x and y?
yeah, so the x is the circumference of the radius.
Yeah, so the radius is x over 2 pi.
Okay.
Yeah. So volume is increasing, volume is decreasing, so the maximum volume occurs at 12. So x max is 12. So if you want the volume of the cylinder to be as big as possible, then you would make this 12. X should be 12. And then answer the question. Well, it's pretty easy, right? It says find the values of x and y. Well, obviously x is 12. What's the fastest way to find y?
18 minus 12.
Yeah, plug it in right there. 18 minus 12, 6. I did the whole problem for you. Yeah, but Mr. Park, there's a B part. I'll give you a B part. So you got this. This is x and y. But now, we're going to revolve it about this side here. So, woof, woof. If you revolve it about the side, then you get a bigger cylinder like that. Find the values of x and y so that the volume of this cylinder will be as large as possible. Well, the volume of a cylinder is pi times the radius squared, but then this one's easy. The radius is x, and the height is y. And again, you got two variables, you got to get rid of one. So again, see, don't reinvent the wheel. Solve for y in this equation, plug it in there, and then you're going to get pi x squared times y, which is 18 minus x. Now, do I even have to do any work? Can you see that this problem, the volume is the same as this problem except for the constant in the front? Okay, here, let me, some of you be fuddled. Distribute the x squared. That's the same thing as this except the constant in the front is different. So do I even have to go any further? No, it's going to be the same number line. Why? Yeah, because the only difference is that this constant, is, instead of 1 over 4 pi in the front, you're going to have a pi in the front. So when you throw the constants on the side, it's not going to affect the number line, right? So the answer is x max is 12 for that problem as well. Why reinvent the wheel? All right. Next. Or you want me to reinvent the wheel? I'm not reinventing the wheel. I wonder if the other calculus teachers spoon feed their students like I spoon feed you. Like you're just like little newborn birds. I have to chew up the food and then spit it into your mouth. Is that what they do too? What do your friends say? Come on, you guys have friends in the other calculus classes. What do they say?
They want to be in this class.
No. Why did you say it louder for the video?
They like their teacher, and we do too.
No, but I want to know, are they being spoon-fed or do they have to do more on their own?
Spoon-fed.
They're being spoon-fed?
Slow-paced spoon-fed.
I doubt that.
It's like their whole class pretty much. Not even taking notes, just doing homework for the class.
Not even spoon-fed, mouth-fed.
I'll give you spoon-fed. 27. Constructing a cone. A right triangle whose hypotenuse is radical 3 is revolved about one of its legs over here to form a cone. Find the radius and height so we get greatest volume. Okay, now, I don't like the picture they have in the book. So did I give you a picture in my notes? Anyway, we had a problem like this before. Let's see if you can remember anything because this might come into play tomorrow. If you have to label x, what would I label x? Should I label this x or this x? Because the book just labels that R and H and then that doesn't give you any hints. But knowing what you know from previous problems, should I label this x or that x? This or that?
So that.
That. Why?
It's
Because then when you use the Pythagorean over here, Pythagorean theorem, you're going to get the square root of 3 minus x squared. Why is it better for that one to be the radical expression?
It's
because you're going to square it. Hope you remember that for tomorrow. I'm sure that will be one of the 3 problems. So the volume of a cone is, and again, you make sure you know your formulas tomorrow. I'm assuming you know all them all. 1/3 pi times the radius squared times the height, which is x. See, then there's no radicals. It's just a polynomial, so it's really easy to take the derivative. Otherwise, if this was the radical, then you got to use the product rule with a radical in it, and it'll still come out, but the algebra is way harder. So throw the constant on the side, and I'm going to distribute this in. Anyway, if you forget to do this and you have the constants in there, it doesn't matter. You're going to factor it out after you take the derivative anyway. So the derivative is, throw the constant on the side, and what's the derivative of this? 3 minus 3x squared. Factor out a 3, which cancels this 3, so you get pi times 1 minus x squared. Now we are ready for the number line. Negative 1 and 1. If you plug in 2, it comes out negative, so it'll be minus, plus, minus, and we don't care there. So the volume increases here, and the volume decreases there. Anyway, now I remember what I was telling you guys. Did you guys even figure out how to play the game yet? The game. Because you have to verify. Look, we're looking for a maximum. Now some of you are going, can't they just know the answer is 1 already without making a number line? No, because verifying it on the AP exam is like most of the points. The answer is only 1 point. Some of you still don't get that. But this is how you play the game. You know the answer is 1, and you know we're looking for a maximum, so you know that it's got to be increasing and then decreasing, right, to get a maximum. And so if it's increasing, then you just put the plus here, and if it's decreasing minus, so you're just kind of like working backwards to play the game. Well, how can they tell which one they write first, what you write first, this or that? They don't know. But usually the students figure this out, you know, when they're doing the problems on their own. But then, so x max is 1. So if you want that volume to be as large as possible, x is 1. Okay, next. 20. Oh, God, I'm kind of ashamed that we got to do that one. It's an insult to your moanings right there. 31. Inscribing, oh, here we go. So we have a cone, and we're going to inscribe it in a sphere of radius 3. How do I draw in the radius to help me solve this problem? Right there, because then you have a right triangle. I think you might see this one tomorrow. And again, which one do I label x? This one. Because you want this to be the radical expression because you're going to square it. Anyway, tomorrow, I might just put the x there so to force you to do it the easy way. So using the Pythagorean Theorem, this is the square root of? I'm not even sure if we have this skill.
9.
Do we have this? So what? X squared minus 9?
9 minus x.
9 minus x squared, okay. Okay, so the volume of a cone is 1/3 pi times the radius squared times the height. Now what is the height of this cone? Imara, what is the height?
3 plus x.
There you go, the height goes like this. See, that's 3, so it's 3 plus x. A lot of people, when they're working too quickly, they just put 2x there, but it's not 2x, it's 3 plus x. Come on, is that your seat?
Hmm?
Okay. Oh. Okay, so we multiply out, or you want to use product rule. Which one? Come on, product rule or multiply it out?
Multiply it out.
Okay, so 27 plus 9x minus 3x squared minus x cubed. So when you take the derivative, you throw the constant on the side like an unwanted pet. So that's 0, 9 minus 6x minus 3x squared. Factor out a negative 3, right? Because you want factor out a negative 3, so you're going to get negative pi times x squared plus 2x minus 3. And look how beautiful that is. That factors x plus 3, x minus 1. So when we make our number line, hurrah! We got negative 3 and 1. And if you plug in 2, it's going to be minus plus minus. we really don't care about this because you cannot have negative values for x. So the volume is increasing and the volume is decreasing. So the maximum volume comes when x is 1. And then you guys answer the question. Make sure you answer the question on tomorrow's quiz now. Hey, wait! We're gonna learn today then. This is not gonna be a short class.
How do we have to learn today?
Because now we gotta go on to the other word problems, which are harder. 32! Hey. Oh, see, like this is like a real life problem right here. You know when you build your house, you know the roof, you know when you have beams, the beams, look at your roof. You know, how come the beams are not like this? How come they just don't have, square beams like that? Why is it shaped like, you guys ever notice the beams that hold up your roof are like this? Why is it like that? How come it's just not square? You know what I'm talking about? Beams.
Because it distributes.
No, because look, if you read the problem, the strength of the beam is proportional to its width times the square of the depth. It's proportional to the width and the square, so the strength of the beam is proportional. What does proportional mean? Okay, let's go back to algebra 2. What if I tell you y is directly proportional to x? What do you write? Y equals
X.
no, kx, where k is called the constant of proportionality. What if I said y is inversely proportional to x? It would be k over x, right? Okay, now let's go back to this problem. The strength of a beam is directly proportional to the width and the square of the depth. K WD squared. How come got a K? Because anytime something is proportional to something, there's a constant of proportionality. How do you know that that's 1? You don't know. It could be 1, could be 3. You don't know. So that's why you have to put a constant there. But you can see it's not going to matter because when we take the derivative, we're going to throw it on the side like an unwanted pet. Okay, but again, we got 2 variables here. We have to get rid of 1. Now look at this picture. What does it say? It says, find the dimensions of the strongest beam that can be cut from a 12-inch diameter log. This is 12. 12 inches. So what is the equation I can write? I need another equation. Look at that. It rhymes with Pythagorean Theorem. Look, you have a right triangle. Use the Pythagorean Theorem. W squared plus D squared is equal to 144. Now, what do you want to do? Solve for D or W?
D.
Well, neither. I want to solve for D squared. Look, D squared is equal to 144 minus W squared. Just plug it in right there. That way you don't have any radicals to worry about. So you got KW times D squared, which is 144 minus W squared. And look, it's a polynomial. So I'm going to throw the constant on the side. I'm going to distribute the W. So when you take the derivative, you throw the constant on the side, and you get 144 minus 3W squared. And when you divide by, factor out the 3, you get 48 minus W squared. So now we are ready for the number line. Wagga! So you got plus or minus root 48. What is root 48? 4 root 3. So 4 root 3, negative 4 root 3. You plug in 0, it's going to be positive, it's negative, we really don't care there. So the strength of the beam is increasing, the strength of the beam is decreasing there. Maximum strength occurs. I guess this is W. So W max is equal to 4 root 3. So if you want the maximum strength of your beam, then you make the width 4 root 3. And what would it make the depth? Root 96, which is... Why don't we just go root 48? and root 96. That's more understandable to you, that's why, right? That's why beams look like this in your house, because they're stronger. Okay, whatever. I just thought of it. I like that problem. That's a good candidate for tomorrow. Actually, there's so many good candidates. I don't know which ones to pick. It's like which of the three is my favorite child? 36. 36. Okay, here we go. So here is the graph of y equal root x. Here is the point 3/2, 0. It says, how close does the curve come to this point? In other words, what is the minimum distance between this curve and this point? See, like, if you're on the curve, the distance from, like if you're here, and you compute all the distances from the curve to the point, all the distances. Which one is the smallest? Probably over here somewhere, yeah? But what is the exact point where it's going to be the closest? That's what we're trying to find. So, we don't know what the coordinates of this point are, so we label it x, comma, y. Well, what is y equal to?
Root x.
Okay, there you go. And we want to, what are we trying to minimize? The distance. We want the distance to be as small as possible. So what formula do you think I'm going to use? The distance formula. So the distance between 2 points is, I hope you guys remember the distance formula, x minus x quantity squared plus y minus y quantity squared. But see, this problem is easy because there's only one variable, only x, so you don't need to write another equation. However, I guess if you put y instead of that, then you would have y here, but then you just can substitute that for y there, right? So that's kind of easy anyway. Okay, now, can you see that when you take the derivative of this, it's going to be pretty ugly?
Yes.
Because what's the derivative of box to the 1/2? It's going to be 1/2 box to the -1/2 times the derivative of box. It's ugly. Yeah, it's manageable, but that's why we have a trick that we use in calculus. Actually, instead of looking at the distance, we look at the square of the distance. In fact, here, I just put d squared. You know why? Because then there's no radical. And of course, well, radical x squared is just x. See? So which one would you rather take the derivative of? The ugly one or the pretty one? The pretty one. So that's a trick that we use. Whenever you use the distance formula, instead of taking the derivative of that, take the derivative of the square of that, because it's just a polynomial. Okay, let's take the derivative. So d squared prime, is that confusing? Maybe I should put parentheses there, equals, now how do you want to take the derivative of this? You want to multiply it out or just think of this as box squared? I think box squared, yes. So 2 box, and please multiply by the derivative of box, which is 1, so you got lucky, plus 1. And then what? You got to make a number line for this, so now you got to multiply it out. So 2x minus 3 plus 1 is the same thing as 2x minus 2, which is 2 times x minus 1. See, so your number line could look nice. So your number line for the square of the distance prime is 1. If you plug in 2, it will be positive here and negative here. So the square of the distance is decreasing, then it's increasing. So the minimum will occur when x is 1. So if you want this distance to be as small as possible, the x coordinate of that point got to be 1. And then you answer the question. Okay, last problem. Finally. Okay, 42. Oh, this is the trough problem, yeah? I'll give you a hint. I think every year for the past 20 years, this has been on the test, this problem. The reason why I like it because it has trig in it. Yeah. So 42. We have a trough. You guys look at the picture, you know where the pigs come and they eat water or grain or whatever. Right? Anyway, there's a trough, and it says this is 1 foot, 1 foot, and 1 foot. And you can vary this angle right here. theta and theta. Okay? What angle theta, how should I bend it? So you have like a piece of metal, right? So you're going to bend it. What angle do I bend it at so that the volume of the trough will be as large as possible? Well, in order for the volume to be as large as possible, the area of this trapezoid got to be as large as possible, right?
Yes.
Right? Because the length of the trough is just a constant. You can throw it on the side anyway. So what angle should I put that so that the volume or the area of this trapezoid will be as large as possible? Okay, now you need some skills from trigonometry, so let's review. If you have a right triangle and you know the hypotenuse and this angle here, how do you label this adjacent side? This is like componentizing vectors in physics, right? H cosine theta. Does that sound familiar? And how do you label the opposite side here? H sine theta. Oh, good. You guys seem to know. Okay, so go over here. Oh, I have a triangle. The hypotenuse is 1. So what's this adjacent side here?
1 sine.
Adjacent. No, it is the opposite side. So 1 sine theta. This is the adjacent side, so it's 1 cosine theta. Why am I writing the 1? That's so dumb. That's okay, I'll just do it for your viewing pleasure. Okay, so we want to maximize the area of this trapezoid. So that means you have to know the formula for area of a trapezoid. Actually, you don't really have to know, because what did your geometry teacher teach you?
Base 1, base 2.
Yeah, well, if you take this piece right here, this triangle, flip it over, put it over here, then you just get a rectangle, right? That's how you find the area of an isosceles trapezoid. However, in calculus, like I told you in August, area of trapezoid is going to be super important in about a month from now, so I think we should just know it. The area of a trapezoid is 1/2 the height times b1 plus b2. That's a formula that you need to know. That's why you take geometry before calculus. So, looking at this trapezoid, 1/2 the height. What's the height? Look at the picture. What's the height? It's right here. It's the height.
Cosine theta.
Cosine theta times b1 plus b2. What is b1? 1. And what is b2? What's this?
1 plus
1 plus 2 sine theta. There you go. This is the area of the trapezoid. I remember, okay, I'll give you a hint. Last year, I just moved that theta to over there, and then all hell broke loose. There you go. So I don't know what I'll do this year. Change the 1 to a 2.
You just leave it like this.
No, well, yeah, probably all hell's still gonna break loose.
But smaller out.
No, I don't know about that. Okay, so if you simplify, this is 2, so you can factor out the 2, which cancels this 1/2, and you're gonna get 1 plus sine theta. Okay, so that's the first problem. Can you get to that step right there? Next, now you gotta take the derivative. Now, should I multiply it out or use product rule? It really doesn't matter. Quick,
Product rule.
because we gotta learn today.
Product rule.
Okay, product rule. Derivative of the first,
Negative.
negative sine theta, leave the second one alone, plus the first times the derivative of the second one. What's the derivative of 1 plus sine theta? Cosine theta. Okay, so this is your derivative. Let's multiply it out. Negative sine theta minus sine squared theta plus cosine squared theta. How do I make a number line for that? Well, I know. Maybe I should put it in tomorrow's quiz. I could put something different on the test. You gotta make a number line for this, people. Come on. Okay, I'll just tell you already. Either change this to 1 minus cosine squared or change that to 1 minus sine squared. Yeah, but since this is a sine already, you want to make everything sine, so change this to 1 minus sine squared. Okay, so what do we got? We got negative 2 sine squared theta minus sine theta plus 1. Factor out the negative sign. I don't like my first term being negative. And does this factor? You bet your sweet bippy it factors. So negative, whoop, 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 whoop. Oh, easy when you copy off the board. 2 sine theta, 1 and 1, plus minus. That's why we made number lines with trig, so that we can do problems like this. So now we are ready for the number line. What goes on the number line? Okay, we're running out of time. I'm just going to tell you. Sine theta equals 1/2. Sine of what angle is 1/2?
30.
Pi over 6 and 5 pi over 6. What about this? Sine of what angle is -1? Oh boy. 3 pi over 2. Okay, I'm just going to test the number line quickly. If you plug in 0, this is going to be negative and positive, but you get a negative. So positive, positive. And if you plug in pi over 2, that's positive and positive, but that's negative. And if you plug in pi, it's going to be positive. See how it doesn't alternate? So if you test the number line correctly, that's what you should get. Yeah, but see, this is where the problem is. You guys just copy off the board. You don't practice plugging in the numbers. Anyway, look at this picture. Look at this angle. Can you see that that angle can't be bigger than pi over 2? That angle can't be bigger than 90 degrees. Otherwise, the thing will bend out of the way. Not going to even hold water anymore. So we really don't care about anything bigger than pi over 2. We only care right there. So right there, the area increasing, the area decreasing. So theta max is equal to pi over 6. So if you want this area to be as large as possible, this angle got to be 30 degrees. There you go. And then you answered the question, however. Okay, we've got 10 minutes left. We're in a heap of trouble. You might have to read tonight. Or wait, no, you can watch the lecture from last year. I think that's posted. Okay, now, the next homework we have, 4.6. We're going to spend 3 nights on this. I believe there's 18 problems also. So 6, 6, 6. So does that mean I'm doing 6 problems tomorrow?
Yeah.
No, come on. These are the 6 easiest ones. The ones at the end are going to be tough, you know. Okay, I'll just do as many examples as I can right now. Okay, so 4.6. This is called related rates. In other words, if you have, okay, let me just give you a problem. Let's say we have a right triangle. Okay, now, so the key to doing related rates problems, things that are changing. See, this is the kind of problems you're going to get. Like this side of the, you know what? I don't want to do, I want to do rectangle. I change it to a rectangle. Let's say I have a rectangle. Let's say the length of the rectangle is increasing at the rate of 3 inches per second or something. So can you imagine that? The length is getting bigger at the rate of 3 inches per second. So like this. Something like that. Can you imagine that? So we say that dl dt is equal to 3. Right? Because the rate at which something is changing, that's the derivative, right? dl dt, but we're doing it with respect to time. Here is the width. Let's say the width is decreasing at the rate of 2 inches per second. So dw dt is -2. Can you imagine that? So the length is getting bigger at the rate of 3 inches per second like this. But the width is getting smaller at the rate of 2 inches per second like this. So 1 second from now, what would the picture look like? It would look like this, right? You know what I mean? See, so things are changing. That's what related rates are. So if something changes, how does that affect the change in something else? Another second later, the length gets 3 inches bigger and the width gets 2 inches smaller. So now the picture looks like this. And it keeps on going, okay? So that's what's happening in this problem. Okay. At the moment when the length is 4 and the width is 3, let's just assume everything is done in inches then, okay? So here, inches per second, inches per second, inches, inches, okay? So this is like, these things are changing, but at this exact moment in time, so it's like a snapshot right there. When this is 4 and this is 3, at that exact moment in time, how fast is the area of the rectangle changing? Question mark. So can you imagine what's happening? This is getting bigger, the width is getting smaller. But at this exact moment in time, when the length is 4 and the width is 3, how fast is the area changing? Like, is the area getting bigger or smaller?
Smaller.
Okay, well let's do the math and figure it out. So the first thing you do, related rates, it's not that hard, but you just got to follow the process. Just like the last section, you write the function, take the derivative, make the number line. Okay, in this one, you got to write an equation that relates the area to these variables here. Now it's easy. What is the area of a rectangle? Yeah, area is equal to length times width. See, sometimes it's easy to write the equation, sometimes not so easy. Second step, take the derivative with respect to time. Now, you guys are used to being, like x is their independent variable, but now x is not the independent variable anymore. It's time, it's t. So watch. So once you write the equation, you just take the derivative with respect to time. So dA dt, that's the derivative of a with respect to time, equals, I see a product here, I'm going to use the product rule. So derivative of the first, leave the second one alone. Plus, leave the first one alone, the derivative of the second. Do you guys understand that we were taking the derivative with respect to time? That's the key to this problem. We're taking the derivative with respect to time. That's why it's all dt's in the denominator there. And then, that's the second step. The third step is you plug in the numbers. So if you want to figure out how fast the area is changing, that's dA dt, all you have to do is plug in numbers for these quantities here. But they're all given in the problem. What is dL dt? How fast is the length changing? 3 inches per second. What is the width? Here, I'm pointing at it. 3. What is the length at this exact moment in time? 4. What is dW dt, which is how fast the width is changing? -2 because it's getting smaller, right? The derivative is negative, that means the quantity is decreasing. And we compute this and you get 9 minus 8, which is 1. Notice that it's a positive number, so that means the area is actually getting bigger at that moment in time. Right? If the derivative is positive, that means the quantity is increasing. So the area is actually getting bigger at that exact moment in time. There might be another point in time where the area is actually getting smaller. And then, on the AP exam, whenever you do related rates, you have to give units. Now, if you're not good at units, like what should the units be? You're trying to figure out how fast the area is changing. What would the units be? Inches squared per second. But if you're not good at units, then just look at this. Just look at this right here. You're finding dA dt. That's area over time. How is area measured? Inches squared. How is time measured in this problem? Seconds. There you go. You always have to give units in this, otherwise that's an automatic 1-point deduction on the AP exam. Okay, we got time for only one more example. Okay, now, so same thing. The length is getting bigger, the width is getting smaller. Let's draw the diagonal in. Look at this angle here. At this exact moment in time, how fast is that angle changing? Now, think about it. If the length is getting bigger and the width is getting smaller, is that angle getting bigger or smaller? Yeah, it's getting smaller, right? It's about how fast is it getting smaller? That's what we want to know. So the first step is to write an equation that relates this angle to the variables that are given. Okay, anybody? There's 12 equations you could write here. Come on, we've got 3 minutes. How about cosine theta is equal to L over the diagonal? Okay, here's the diagonal. I wanted to do the diagonal, but we just don't have time. So, okay, we don't even have the diagonal, so I guess there's only 4 equations we can write there. How about tangent theta equal W over L, right? Opposite over adjacent. Or how about cotangent theta equal L over W? Okay, which one you like better, tangent or cotangent? Okay, so tangent theta is equal to W over L. Now, you could take the derivative of this equation, that's not a problem, but what are we trying to find? How fast is the angle changing? We're trying to find the theta dt. So it would be a lot easier if you could solve for theta. So how can I solve for theta? Tan inverse both sides. So you get tan inverse W. Now it really doesn't matter which equation you use. You're going to get the right answer anyway. But since we're trying to find the theta dt, it's just easier if you solve for theta. Okay, now that's the first step. Write an equation that relates to variables. Second step. What did I tell you? What did I do in this problem? Take the derivative with respect to time. So the theta dt is equal to, okay, now I got tan inverse box. Now you got to know your derivatives. What's the derivative of tan inverse box? 1 over 1 plus box squared times the derivative of box. I see a quotient. I better use the quotient rule. So low d high minus high d low all over denominator squared we go. We're still using all the same rules. Nothing changed. The only thing we're doing different is we're taking the derivative with respect to time. And then what's the last step? Were you here 5 minutes ago? Plug in the numbers. It's a three-step process. Write the equation, take the derivative with respect to time, and then plug in the numbers. Okay, can we do this quickly? 1 plus, what's W? 3. L is 4 squared times L, 4 times dw dt, negative 2 minus W, which was 3. dl dt was 3, all over L squared, 4 squared. There you go. Now, since we're running out of time, can I assume you can compute that number? That's a bad assumption, yeah? Okay, let's do this quickly. 1 plus over 1 plus 9/16 times negative 8 minus 9 over 16. Now, what do you want to do? You want to distribute this 16 down here? So you're going to have negative 17 on the top. If you distribute the 16 on the bottom, what do you get? Distribute the 16. 16 plus 9, so that's negative 17 over 25. Okay, that's the correct number. Now for the units. If you're not good at working with units, just look at this. We're finding d theta dt. Angle over time. How are angles measured?
Radians.
Radians. We never do degrees. And how is the time measured in this problem? Seconds. So at this exact moment in time, this angle is getting smaller because the derivative is negative at the rate of 17 over 25 radians per second. Okay, so your homework tonight is the first 6 problems. These are the easy ones now. And then they're going to get really tough, where we got to use similar triangles and whatnot. Woo! We could have finished way earlier if you actually did some of your homework. But whatever. No, don't you touch that. Come on, did you even do any of the homework? You're on camera. Did you do your homework? I think we know the answer.
Probably.